Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. In this video, we are going to see the introduction on complex numbers. This is part 1 of the 4 parts on complex numbers, which is going to be coming up next. And in this video, you'll be learning how the complex numbers were introduced and how to represent a complex number. So let's proceed into the video now.
The first mathematical idea that came into the world was counting numbers 1, 2, 3, and 4, and 5, and etc. So they needed something to count their cattle. That was the first time when they started using mathematics. So this was the set of numbers which came first, and these numbers are called natural numbers or simply counting numbers. Next came the wonderful number called 0, which came from Hindu system, and this 0 was the base for all our number system. The total number system is based on this 0 and the position where the 0 is placed. So this is that's why the number system is called Hindu-Arabic numeral system, and in this system we use 0 to 9 as our basic symbols for representing different numbers. And then came negative numbers. What are negative? How did they come into the picture? So, negative numbers were first introduced when they wanted to talk about loss, debt in finance, and maybe debits. Credit was positive and debit was negative, and even in solving problems like say 2x plus 4 equal to 0, and very simple problem like this they couldn't solve. So at this point, they when they didn't have negative numbers, they said there was no solution for this equation. Can you imagine? There was no solution for this equation. And then they started introducing, okay, let's start having something called negative numbers, which means they are just opposite to the numbers that we have. So these were added to the set of numbers. So we had negative numbers. Sometimes negative numbers also show the opposite directions. Where the positive numbers show one direction, then its corresponding negative number will show the other direction. So this is how negative numbers came in. Okay, what happened next? Next, they had problems with fractions. So what happened? The fractions were like part of the whole, and they wanted to say show what is 3/4 or 1/4 or simple fractions like this, something like 5.5. So they needed fractions. So what happened? They introduced fractions in between those big numbers, right? So the fractions were part of the whole. So where every place in between two whole numbers there were fractions, and they were into two different categories. One are recurring or terminating fractions, which is terminating decimals. When fractions are written into decimals, we call them as recurring or terminating decimals. And these type of fractions where when you simplify they are recurring or terminating decimals, they are called rational numbers. So we had rational numbers in between. Say this is 1.5, and you had rational number in between 2 and 3, and there are rational numbers in between 1 and 3, 1, 0 and 1. I can say, for example, 1/3. And there are other fractions which had non-recurring and non-terminating decimals. Very good example for this is rational number square root of 2, square root of 3. So when they started using Pythagoras theorem, and when they started getting square root numbers, then they named this as irrational numbers, because they are called surds as well. Irrational numbers, just opposite of rational numbers. Rational numbers are recurring and terminating decimals, whereas irrational number are non-recurring and non-terminating decimals. Okay, so you have rational numbers in between. Square root of 2 somewhere here, and square root of 3 would be somewhere between 1 and 2, and square root of 4 is actually 2, and square root of 5 is in between 2 and 3, and so on. So you can always plug in both rational and irrational numbers between these set of integers. That's what we call. So natural numbers came first, and then 0 came next, and then negative numbers came next, and then the rational numbers, and then the irrational numbers. And rational numbers and irrational numbers together are called real numbers. Okay, so real numbers contain all the numbers. In fact, any number 4, as I said, can be written as square root of 16. So any number, natural or negative or 0, can be written as irrational or rational number, right? So 3 can be written as, say, 6 over 2, which comes under rational number. So any number can be written as either rational or irrational. So real number is actually two sets, rational or irrational. Okay, so all these numbers could be put up on a number line 0, 1, 2, 3, and this number line is called real number line. So far we have seen how the numbers were formed, and we are satisfied with all these numbers, natural, counting numbers, negative numbers, zeros, integers, rationals and irrational, all together put up as real number set. And we are okay with this until we came into something called square root of a negative number, and this is where we had problems. So you should have noticed in this place that in fact this equation did not have solution until they introduced negative numbers. If we start solving this equation, the quadratic equation, and using the quadratic formula, we get minus 1 plus or minus square root of minus root 3 over 2. And here came the problem. We don't know what is root of negative 3. And we had so many other questions of the same type. We had this negative root number, root of a negative number in many areas. And then, okay, they thought, why can't we name this? Why can't we just have another set of numbers? And they call this set of numbers as imaginary numbers. And actually the imaginary number is based on square root of minus 1. This is the imaginary number. So any number which is, say for example, minus square root of minus 3 can be written as square root of 3 times square root of minus 1. So square root of minus 6 can be written as square root of 6 times square root of minus 1. Right? Square root of 4 minus 4 can be written as square root of 4 times square root of minus 1, which is 2 times square root of minus 1. So all these negative numbers within the square root can always be expressed as a multiple of square root of minus 1. So they called this number as imaginary number, and they gave a letter I to this, and this is called otherwise as complex number. And this is a very interesting topic actually. If you're interested, there is a lot of things to research about this. Why this number? Why are these names given complex and imaginary number? And why is the letter I used specifically of all the letters? Why is this I used in this? And who, when, and how exactly did this concept come into existence? All these things could be researched, and it makes a good research topic for students who are interested in this. Okay, let's proceed. Now, this can be written as minus 1 over 2 plus or minus square root of minus 3 over 2, right? Which means I can write this as minus 1 over 2 plus or minus square root of 3 square root of minus 1 over 2 as I explained here. Okay, this is minus 1 over 2 plus or minus square root of root 3 over 2, and I said square root of minus 1 is I. So this is how a complex number actually looks like. Okay, it has a number plus or minus anything. It could be plus or it could be minus some number with an I with it. So you have two parts of a complex number. This part is without I, and therefore this is called real part, and this part with I is called imaginary part. So we just saw a complex number would look like a real part plus a imaginary part times I. And you should have noticed that both these things are real numbers. Just because you have the I with it, the total number is called a complex number. Okay, so any complex number would look like A plus IB, where A and B are real numbers. Okay, this is a general definition of complex number, where I is a very important thing which is always equal to root of minus 1. So when I equal to -1, a lot of other interesting concepts come from here. What's I square? I square is square of square root of -1, which is -1. And what's I cube? Which is I square times I, which means -1 times I. So we get I cube as -I. So what's I power 4? I square times I square, right? And I square is -1, therefore -1 times -1 is 1. It's very interesting to note that you get 1 at I power 4. And what happens to I power 5? I power 4 times I, right? So I power 4 was 1 and it is I, and you get back I for I power 5, and it in continuous I power 6 is -1 because it's I times I, and so on. Okay, this is very important concept. This is a very wonderful concept actually about complex number, and this is just an introduction of what is a complex number. And hope to meet you in the next video. Bye bye.